Kia ora, everybody. We're now up to programming this particular challenge. Don't forget, our challenge is to use an input. We have a switch as an input today, a really, really basic input. I've gone and I've made that, I've gone and made our little diagram just a little bit bigger so that you can see it a little bit better. Maybe I'll make it even bigger still. Look at that. We have, one more time, our Raspberry Pi. We have our red LED connected to pin 15, GPIO pin 15. Our green LED connected to GPIO pin 13, connected to a resistor, 330 ohm resistor to this leg. We have our LEDs connected up to ground to make a complete circuit. So the positive leg is this way, the long leg, short leg is that way, connected up to ground. We have don't forget about the 330 ohm resistor on that red LED as well. We have our positive connected here. We have our negative connected here. Our 3.3 volts connected to this rail. We have ground 0 volts connected up to this blue rail down the back. Okay, we have a push switch here. We have a 10K resistor here, and the other leg of the push switch is connected up all the way to GPIO pin 0. This is currently still running the correct code. We're going to fix that in a second, and then we're going to remake this code from scratch. I think we can hide this for now, and we'll come back to it. All right, bye-bye. And let's minimize this one and boot up Thonny. Okay. First thing I want you to do when you get to Thonny, is I want you to make sure it's on the screen and fully on the screen as much as you can. Hey, that's a little bit better, isn't it? First thing I want you to do when you get to Thonny is I want you to check down the bottom. Where's my hand? There it is. Can you see this? Can you see MicroPython? Board in FS mode, something, 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 something. What does that say down the bottom? If it says something wildly different, if it says we're using the local Python, your board is not connected. You need to make sure that you go through and connect your board. Make sure you have MicroPython flashed on here. Hopefully it still is from your last previous lessons. Okay, let's go. What are we going to do today? First thing we need to do is I'm going to erase its memory. So I'm just going to save that, and I'm going to run that, and that's going to send that out to the board. And why do I have all these variables? I'm going to stop it, and I'm going to run that. And now it's forgotten everything, and nothing is working at all. That's fantastic. That's exactly what we want. Okay, we need to do some importing. So we're going to say from machine import. Oh, you can barely see me. That's okay. Import pin. Let's see if I can get a little bit closer. No, I'm not going to play with it too much. From machine import pin, we are getting the pin library. We're bringing it in. Well, no, we're getting the pin object from the machine library. That gets a little technical, but that's okay. We now know what a pin is. Somebody else has written some code to tell us and tell the Pico what a pin is, so we don't have to do that. We're also going to import time. We're going to need that again. Import time. Cool. We're also going to... okay, next thing we need to do is we need to grab our LEDs. So let's make our red LED variable, and we're going to set that equal to pin. And don't forget the capitals, the brackets, and all of the syntax, the commas, all of the punctuation-y things. Make sure you're seeing dots, not commas. Make sure you're closing the brackets. Make sure they're all paired up. It's all super, super critical. So red is currently on pin 15, and it is a pin.out. Ooh, maybe you notice now why it's pin.out, because we're using both pins as input and pins as output as well, and we need to tell the program which is which. We have a green LED, and that is a pin on pin 13, isn't it? If you decided to be clever and use different pins, make sure you're patching it up here. That is also pin dot out. And okay, we now need a button. This is actually going to be our input. So let's make a button. By the way, these variable names do not matter as long as they are consistent. They could be called hot dog. They could be called unicorn. The variable name doesn't matter, but we name them sensibly. Doesn't it make sense to call it button? We only have one button here. Button is not a pun, it's a pin. And that is on pin 0. And that is a pin dot in. And one more thing here, pin dot pull down. Okay, why? Why pin dot pull down? Here's what happens. We are using this pin to detect a voltage. Either it is no voltage, and we show our red LED, or it is high voltage, and we show our green LED. The circuit is complete, there's electrons flowing, hey, and it can read that voltage, and we show our high LED. But what can happen is if we don't tell the Pico, make sure, if you're not seeing a voltage, to actually make sure that there's no voltage on there. It can kind of float around a bit, and it just gets a little bit wobbly, and it can detect that floating thing, and it can misfire. It can think that you've triggered the switch, and you haven't. So we have to make sure that we say, drain everything. There is no voltage on here unless I tell you that there is, unless you detect it. So please pull that voltage down, make sure it's down, and then when I close the switch, that's when the switch is pushed, when you see that voltage spike. Okay, moving on. Cool, let's set up an infinite loop. Can you remember how to do that? While true. While we have some condition, and then loop and loop and loop and loop and loop and loop forever. Okay. We're going to do something we haven't used before. This is a conditional. This is an if statement. If the button is pressed, how do we know if the button is pressed? Well, we're going to go to the button, and we're going to check its value. If its value is 1, it's reading a voltage. Our button is closed. We can do something, okay? Let's say if button dot value, hey, go to the button, check if it's pushed or not. Double brackets after that value, open and close brackets just at the end, parentheses. If it's 1, colon, let's just add in here. Notice my tabbing. Notice my tabbing. 1 tabbed in here, 2 tabs in here. We're inside a second code block. If button.value is 1, then the button is pressed. What do we want to do? We want to turn our red LED on, our green LED off. Is that backwards? I think it's still backwards, but it's what my code says. So we're going to stick with that today, and you can fix it being backwards. Our red LED dot value is going to be true. Our green LED dot value is going to be false. Turn on the red LED, turn off the green LED. Are we done? I'm just going to add a little comment up here so that we remember what this means. I'm going to put up a little hashtag. That's a comment. Python will ignore the comment. Button is pressed. Okay. And then else, if the button is not pressed, a little comment up here as well so that we know what's happening. What are we going to do? We're going to do the reverse. I'm just going to copy paste that. Too lazy for typing the whole thing out. Oops. Fix the tabbing. Make sure the tabbing is correct. Tabbed in once for the while loop, once for the else block. There we go. Flip these booleans. False becomes true. True becomes false. Cool. And now just something a little bit technical. We just have to do this for technical reasons. What can happen is if you push the button, Python is running very, very fast. Thousands of times a second this loop is going around and around and around and around. Thousands, hundreds of thousands of times this loop is going around and around and around. What can happen is it can detect you pushing the button multiple times a second. So we're just going to put a little delay. Please don't check more than 20 times a second. Is that enough? Cool. Small delay. That's going to stop something. This is going to stop something called bouncing. This is going to debounce our input. A little bit fancy, but we're just going to add it for now. It's a shortcut for debouncing. Let's just add it in. Time.sleep 0.05. Close that bracket off. I'm going to put a little comment in here for debounce. D-B-O-U-N-C-E with debounce. There we go. Should we run it? Are we good? Did we get this in one shot? Let's find out. Here we go. Hit run. It's rebooting. You can't see it because it's not on the screen. Let's bring it back in. Oh, here it is. My green LED is on. Hey, presto. Everything is working just great. It may not be working just great for you. So, if it's not, what do we do? First thing. Check. Whoops. Read the shell. Is there an error message? What does it say? Google that error message. See if it's correct. Oh my gosh. You're not able to see the top of my code the whole time. Bring that back down. There it is. Make sure your pins are correct. Make sure your syntax is correct. If all of that seems okay, go through and double check the circuit. Check all of the connections. If you really, really have to, even get out the multimeter to check. Anyway, this is a really involved project. We're not going to be doing too much more involved in this. All we are going to be doing from here is we are going to be changing the input. We're going to change this for a different type of input, and we're going to change the output. So we're going to change what our output is going to be. Your final project for this is going to be some circuit with an input and an output, and that is it. So we're just going to change up what kind of inputs could we have? What kind of outputs could we have? Could we have a servo motor? Could we have a display? Could we have some kind of message sent to your phone? Could we have a moisture sensor? Could we have a CO2 sensor? Could we have any other kind of sensor in place of this input? That's it. That's all for now. I hope this worked for you, and if it didn't, I hope you managed to successfully debug it. Ka pai. Ka pai tō mai. Ka kite e hoa. See you on the next one.